Hi all. So today we are going to solve this Leetcode 788 rotated digits. So in the question you are given an integer x is a good if after rotating each digit individually by 180 degrees we get a valid number that is different from x. Each digit must be rotated. We cannot choose to leave it alone. A number is valid if each digit remains a digit after rotation. For example, 0, 1, 8 rotate to themselves. So if you're given 0 and if you rotate it in any direction, it stays 0, right? Similarly for 1, if you rotate it by 180 degree clockwise, anti-clockwise, or if you, even if you flip it, so it stays 1. And for 8, it stays 8 only, even after any directional rotation. 2 and 5 rotate to each other. So if you do a flip, so by 180 degree, it becomes 5, and similarly 5 rotates back to 2. 6 and 9 rotate to each other. So if you are given 6 and you rotate it, so it becomes 9. And if you rotate 9, it becomes 6 again. So you basically 2, 5, 6, 9 are your good digits. But 0, 1, 8 are not good. And if you rotate 3, 4, and 7, these don't become a digit itself, right? So these are bad digits, invalid digits after rotation. So you are given an integer n. You need to return the number of good integers in the range 1 to n. So if you are given n equal to 10, then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are these 10 numbers present, right, in the range of 1 to n. And only 2, 5, 6, 9. So these are only the good digits here, or basically good numbers in the range, right? But let's say you are given a 2, 1, 8, 5. So after rotating each digits, it becomes 5, 1, 8, and 2, right? So this is also this is a different number from the original number itself after rotation. So it is a good number. But if you are given like let's say 1, 8. So if you rotate each digits here in 1, 8, it stays 1, 8 only. So this is not a different number from your original number. So that is why it is not good. If you are given let's say 2, 1, 3, and we rotate each number, so 2 becomes 5, 1 stays 1, 3 becomes some invalid digit itself. So this is also invalid number, right? So this is not a good digit. So let me walk you through some observations, and from there we will try to get some intuition how to solve it. So there are basically three cases. Either the number could contain 0, 1, 8, or could contain 2, 5, 6, 9, or 3, 4, 7. If any of the digit present in number is 3, 4, 7, it is invalid, right? And even if it is in combination of any of the neutral or good numbers. So let's say you are given a number 2, 1, 8, 3. So we have 3 here, right? So the last digit we will see is 3 itself. So there only we can say it is invalid number. We don't need to increment the count. So if you have number 2, 1, 8, 5, so after rotation it becomes 5, 1, 8, 2. So we take the last digit and see if it is a good number or not. And if it is good, then we need to check if the previous number that we had was a good number or a neutral number or a bad number. If it was a neutral and it is a good number, then overall it is a good number, right? And so we will divide this number into two parts. One is the new number that we are coming into, and one will be the previous state. And if we keep track of this number, if 518 is a good or no, so then we can directly decide from the current number itself if the what is the overall state of the number, right? So 518 is a good number, right? And if it is 2 is good, then it is overall a good number, right? If this previous one was bad, let's say you had 5382, so we see this last digit as good, but the previous state at 538 is a bad number, right? So overall it becomes a bad number. So we will apply DP here to check in the range of 1 to n and get a count of how many good numbers are there. So we need to store DP of 0. The 0 number, this represents the number, would be a neutral number, right? So we will store 1 in here. Similarly, DP of 1 would be 1 here. So if your, let's say, DP of I represents any state of any number, where I is the number, then DP of I would be 1 if I is in 0, 1, 8. We will store 2 if it is in 2, 5, 6 or 9. And we will store 3 invalid if it is 3, 4 or 7. Any of that. So for first 1 to 9 range, we will store these numbers. And from any number onwards, so let's say we have 15, right? So we will get mod it by 10 and to get the last digit. So the last digit is 5. So we can check whether DP of 5, what is it. So DP of 5 is in a good state, right? So this is 2, that is good, right? The value would be 2 for 5. And if we divide it 15 by 10, then we will get 1, right? So we will check DP of this previous state, DP of 1, that is neutral, so 1. And this combination is basically a good number, right? So I hope you got some idea like how we can iterate from 1 to n and take account of all the neutral numbers that we strike on, and we'll maintain this state as we go forward and check the previous states for finding out any new state. So in the solution, I have maintained TP of n plus 1 to and initialize the DP of 0 as 1. And there are 3 cases. So 1 represents 0, 1, 8, and 2 represents the good numbers, which is 2, 5, 6, 9, and 3 represents the invalid number, that is 3, 4, and 7. And we iterate from 1 to n, and we get the last digit, and this is the previous digits. So for the last digit which we are currently encountering, if it is between 0, 1, and 8, it means the current number is the last digit is neutral number, right? And we simply store the previous state into our current state. So this is the current state. If this current digit, the last digit, is any of the good number, then we need to check if the previous is either neutral or good. Then only we store a good number in the current state, or else we will simply put a invalid state into the current state. So invalid number 3 represents the invalid number, and that's what we are storing. And if the last digit itself is a bad number, so it is not, it is between 3, 4, and 7, then we simply put 3 into our current state. And we increment our count whenever we visit a good number in the range 1 to n. And that's how we are identifying how many good numbers we have encountered. And that's what we are returning. Yeah. Hope you like the solution. Uh, uh, Thank you.